The global demand for artificial intelligence and cloud computing is accelerating at a staggering pace. Every prompt, every automated task, and every query demands a massive amount of physical power to process. Every digital action happens on a physical machine. When you pack millions of those processors together inside a single facility, they generate a compounding amount of heat. Traditionally, we cool these machines using large, mechanical air conditioning systems. This requires vast amounts of electricity, putting incredible strain on urban power grids that are already struggling to keep up. Maintaining the digital economy requires a massive, heavy, and incredibly hot industrial engine, currently searching the globe for a place to cool down. The Lefdal Mine data center in Norway resembles a remote fortress, a physical manifestation of the industry's shift toward the Nordic North. Up here, the climate itself does the heavy lifting. Facilities pull in freezing outside air to cool the servers, while local hydroelectric dams provide abundant, renewable electricity. Inside, immaculate rows of black server cabinets operate with high efficiency, supported by the combination of freezing temperatures and cheap power. Locating the brains of the modern economy thousands of miles from industrial centers creates a severe physical vulnerability. These Arctic facilities function as fragile machines, entirely dependent on a massive, hidden physical ecosystem for their survival. Building one of these facilities in the wilderness requires a staggering physical footprint. Moving heavy construction materials and earth-moving equipment into the frozen north is an enormous undertaking. Standard supply chain models fail here. Semi-trucks navigate dangerous, ice-covered grades, while severe weather frequently shuts down road networks during a brutally short construction season. Distance compounds every minor issue. The single storm-delayed shipment or one missing spare part can halt routine system maintenance. Engineers must design for total isolation. They build massive on-site warehouses for pre-positioned spare parts and install redundant power and cooling systems so the facility survives even when it is unreachable. In these environments, shipping and logistics dictate the technical design, becoming the core engineering challenge of the project. This map shows an isolated Arctic node. Redundant power grid pathways guarantee electricity during extreme weather, but power means nothing if data cannot reach users. Thousands of miles of subsea fiber cables branch out, connecting remote servers to distant continents. Maintaining those connections requires specialized ships operating in open water. Severe ice conditions make emergency submarine cable repairs dangerous and difficult. Hyperscale providers in the north prioritize guaranteed reliability against a hostile geography above processing speed or raw storage capacity. Highly automated computing remains entirely dependent on human hands. The technology running inside these servers spans the globe, but the physical operation remains intensely local. A facility requires round-the-clock expertise. Electricians, network specialists, mechanical engineers, and security teams stand exposed to the elements to maintain high-voltage infrastructure. Operators face immense difficulty recruiting and retaining specialized technical talent in isolated, freezing communities. Even the most advanced, unkillable machine will collapse without a dedicated local population willing to endure the climate to maintain it. The future of the internet depends on a geographic trade-off between the urban model and the remote Arctic model. Urban centers provide immediate proximity to customer bases, deep pools of technical talent, and dense, pre-existing network hubs. The Arctic provides abundant land and free cooling, but these natural advantages must constantly compensate for the logistical penalties of extreme distance. The global computing ecosystem is fracturing into a distributed network based on this cost-benefit analysis. An isolated Arctic facility serves as the visible tip of a massive hidden logistical web required to keep its servers glowing. As the global demand for computing power accelerates, mastering physical geography is the mandatory prerequisite for the digital future. In the most extreme environments on Earth, resilience cannot be added as an afterthought. Resilience is the infrastructure.